Welcome to the final video of the AP Calc Summer Assignment Series. This is on the final section of the packet, Section N, which deals with solving trig equations. So this really puts everything together from what we've done in the last few sections about trig. You're going to need to know a little bit of some identities. They might pop up in some equations. You're most certainly going to need to know your unit circle because in order to undo these equations, without a calculator that is, you're going to need to know the special values. Now, I'll be honest with you, on the AP exam, if you have to solve a trig equation and they don't let you use the calculator, more often than not, the solutions will be those special angles. Pi over 3, pi over 6, your quadrantal angles, etc. Okay? If you are allowed to use your calculator, then possibly it's not going to be a nice angle. All the problems in the packet, because again, I wanted you to not use your calculator on it as much as possible, will be those nice special angles. Maybe not necessarily on the first quadrant, but they will be the reference angles to those special angles that are in your table that I have you to memorize in the packet. All right, let's do some problems, some example problems. Now, for starters, all of these problems are going to be solved. The interval from 0 to 2 pi, okay, with 2 pi being open. And that's because, as you know from seeing graphs of trig functions, because it's a periodic function, because it continually oscillates without end, we're going to have an infinite number of solutions to these equations if we don't restrict where our answers will come from. But I want you to have a finite number of answers, so I'm going to tell you, at least for these, just solve it one repetition around the unit circle from 0 to 2 pi. Okay, let's look at an equation like something like this. X cos x equals 3 cosine x. Okay. I have x's on either side of the equation, so perhaps I want to move all the x's to the same side. So why don't I bring the 3 cosine x over to the other side? I wouldn't want to divide out the cosine x, okay? By doing that, we're going to lose some of the solutions to the equation. Instead, I would rather bring both of the cosines to the other side, because now look what I can do. I can factor out that cosine x, and I get two things that multiply to 0. So that means the solutions of this equation will be the values of x, which makes cosine x equal to 0, and the values of x that make x minus 3 equal to 0. Well, we'll do that one first because that's easy. X equals 3 is a solution to this equation. Now we've got to think about our unit circle, and we've got to think one go-around of the unit circle. Where is cosine x equal to 0? Where is my x-coordinate 0? Well, I believe that's going to be some of those special quadrantal angles. X can be pi over 2 and 3 pi over 2. Okay, notice because the directions told me to go from 0 to 2 pi, I'm using radians. I'm not saying 90 and 270 degrees. That's important. On the AP exam, we're almost always going to be dealing with radians. Actually, not almost always. 100% of the time, we're going to be dealing with radians when we deal with trig functions. Okay? So get radians down. Let's look at another example. Let's try 3 tangent squared x minus 1 equals 0. Okay, well, I only see one trig function, this tangent squared x, so perhaps we want to try to isolate for that. So let's bring the 1 over. 3 tangent squared x equals 1. We'll divide through by 3. I get tan squared x equals 1/3. But I want maybe tan x. If I take the root of both sides, now I get tan x equals plus or minus root 3 over 3. Okay, so I look back to my unit circle and I think to myself, where is tangent either positive root 3 over 3 or negative root 3 over 3? And it turns out it's going to be 4 angles because basically there's one for each of the quadrants. Because since tangent here is either positive or negative, we're not really worrying about, reference angles for specific quadrants. We're going to look at the reference angles for all 4 quadrants. So in the first quadrant, pi over 6 is when tangent is equal to root 3 over 3. So we're just going to get the other 3 reference angles for that for the other quadrants. So we'll get 5 pi over 6, 7 pi over 6, and 11 pi over 6. That's going to be the 4 solutions, for this equation. Let's look at one more. Let's look at one that's a little bit more complicated, and you'll see why when I write it down. Let's do 3 cosine x equals 2 sine squared x. Okay? Why is it complicated? Well, this is the first one where I have two different trig functions in the equation. So I can't just bring it all to one side yet, per se. I want to have it in terms of maybe one of these two trig functions. Well, notice that I have a sine squared x. Notice, too, that we can use, perhaps, our Pythagorean identity to rewrite this in terms of cosines. Remember that sine squared x plus cosine squared x equals 1. So if we subtract the cosine, sine squared x equals 1 minus cosine squared x. So perhaps let's make that substitution first. So I'll rewrite sine squared x as 1 minus cosine squared x. All right, now we're getting a little bit better. Now let's try to bring everything to one side. Let's distribute the 2. So I get 3 cos x equals 2 minus 2 cosine squared x. All right. Now, I have a cosine x, I have a cosine squared x. This is basically a quadratic in disguise. Let's get one side of the equation equal to 0 and write it in descending order of power. So I have 2 cosine squared x plus 3 cosine x minus 2 equals 0. I am going to now factor this equation basically the exact same way I would factor 2x squared plus 3x minus 2. Except instead of using x's, I'm going to use cosine x's. So, why don't we factor this as, well, I've got to have 2 cos x and 1 cos x in my first positions. And then I want to think about two numbers that multiply to negative 2 in such a way that when I FOIL, I'm going to have a plus 3 cos x in the middle. So if I do plus 2 and minus 1, I think that fits the bill. And if you FOIL this out, you will get the last step back. So we want to set each of these factors equal to 0. So we'll do 2 cosine x minus 1 equals 0. So cosine x will equal positive 1/2. So if we look, when will that happen? That's going to happen when x is at, in the first quadrant at least, when x is at pi over 3. But now remember, we only want positive 1/2, so we got to also look for the reference angle of this in the fourth quadrant, because that's the only other quadrant where cosine can be positive. So 5 pi over 3 is going to be the other solution to this part of the equation. Now look at the other factor, cos x plus 2 equals 0. Well, if we isolate this one for cosine, we get cosine x equals negative 2. And as we all know, the range of the cosine function is only from positive 1 to negative 1, so there's no x where cosine x can be negative 2, so this part has no solution. So pi over 3 and 5 pi over 3 are the only two solutions to that equation. Okay, I hope this gives you a nice little refresher on how to solve some trig equations. Best of luck as you complete the rest of the assignment. For those of you that have watched some of these some of these videos in this series, I appreciate it. I hope it's been very helpful. If you have any questions as you go through the packet this summer, please feel free to let me know. Otherwise, I look forward to seeing you on the first day of school, ready to start some calculus. Have a great rest of your summer.